مش الحال full screen باين
Yes,
السلايد.
yes, full screen. Yes, you can start.
Okay, so hello, doctor. Today I'm going to be talking about how to overcome the intermittency of renewable energy, which is a very... Hello? Hello?
Yes, Mahdi, I hear you. I am hearing you. Just I mute myself so that I can
Okay.
hear you well.
Okay, this is better. Okay, Tamam. Thank
Okay.
you. So
Yeah.
I'm going to be talking how to overcome the intermittency of renewable energy, which is a very prominent issue in today's modern transition from fossil fuels to renewable energy. So first of all, let's define renewable energy briefly. It's energy that comes from naturally generated resources. They can be replenished. They are non-ending. They come from wind, solar, hydro, tidal, geothermal, and biomass. They're the most prominent and currently used renewable energy. And they aren't new, actually. They used to be used way back, like windmills, sails, grinders, but they have been commercialized as of 1800s. So what is the current status of renewable energy? By 2019, 11.4% of the world's energy demand came from renewable energy. We had a huge growth in investment, uh, almost quadrupled from 47 billion to 280 billion between 2004 and 2017. And this actually is being progressed with countries trying to follow the Paris Agreement. All countries of the world signed the Paris Agreement to try and keep global warming below 2 degrees Celsius before industrial times by 2030. So let's talk about the issue. What is intermittency of renewable energy? So as we know, we don't have 24/7 is a supply of renewable energy. We don't have the sun all the time. We don't have the wind all the time. So we are being controlled by weather conditions. And these irregular alterations cause intermittency. So the critics have very rising concerns towards this. Like, are we actually trying to go further towards something like renewable energy that gets us more dependent on like it's not very a reliable source of energy? For example, solar photovoltaics and wind turbines function best when there is sun or when there is wind at optimum conditions. So do we really want to transition into that kind of energy? How will we if our energy mix depends mainly on that, how we will survive? So what are the problems? So today's current energy mix is built on continuous availability. We demand what we supply what is demand. The grid actually has a little buffer between supply and demand. The current energy grid has very little storage capacity. So there isn't storage is not very integrated in today's modern or typical conventional grids. So it's challenging to add more renewable energy without taking proper measures. That without these measures, we're going to be compromising energy security and supply reliability. And with that, we are at stake of continuous blackouts and at mercy of varying natural elements. So what is the current problem with the grid? It's very non-controllable in the means that it's hard to integrate more energy, renewable energy into it. It has limited inlets and outlets of renewable energy, and that will put us at mercy of disruptive elements. So as I'm going to say now, so if we're going to add more, if we're designing, for example, for solar, I'm going to give the example for solar energy. So when designing for solar energy integration, we need to accommodate that we have sudden fluctuations in the energy, and not just from day to night. Actually, within the same day, we're going to have cloudy weather and non-cloudy weather, and this affects the energy supply. So when the grid operators actually want to take that into consideration, it will make their task much harder. They need, because energy operators usually know for fossil fuels, for example, for oil, that we need more energy, we supply more coal. We need more, or even oil or fuel oil. But in the case of renewable energy, they have to plan the day ahead or the week ahead or even the month ahead, taking into consideration the predictability of weather and so on. So what's next? Is it really, if it's really that that's a problem of having renewable intermittent energy? So, but it's not actually impossible to overcome it with proper advancements in technology, changing consumer behavior, how we deal with energy, and today's modern and making modern energy policies to suit all that. So now we will discuss about methods and means of how to overcome these issues. So here, and the main solutions we'll be talking about are energy storage, net metering, fossil support, mainly natural gas, low consumption appliances, cross-border grids, and other supplementary solutions. So first of all, with energy storage. So if we're saying that the main problem is that if we don't have solar energy, we're being cut out of the grid. We're at this mercy. So why not have storage or batteries to fill the excess energy and use them when we don't have that solar power, or better yet, when we're at peak times during the solar power generation. Why would we let all that energy go to waste? We should put them in storage so that we use them and not and have a high energy efficiency by in which we are using all the energy we're producing. We don't want anything to go into waste. Usually, in very traditional and conventional methods, we're using chemical alkaline batteries, lithium batteries. But now, as if we want to progress this even more, and put it on a large scale grid level, we need to take into account that we need better projects or large scale batteries. So how are we going to do that? So in this example, this is the alkaline battery storage, for example. But if you look into it, we see, can you see a pointer? Okay, so if we look into it, like, can you see how many small batteries you have inside?
Yes, I am seeing it. I am seeing it.
Yes. Okay. So if you can see how many small batteries are there in this energy unit, and this is actually on a long term and a large scale way, it's not actually feasible to go further into it. Okay. So now we have to consider that electrochemical batteries are not the optimum solution, and they are not very promising right now. So work is in progress to make them more safe, of adequate capacity, and acceptable shelf life and cycle life to compete in cost and convenience with the chemical energy stored in fossil fuels. And we also know that in alkaline and lithium batteries, we have a limitation in terms of reversible chemical reactions. So we have a certain shelf life or cycle life. So we need bigger packs, and work is in progress for that, and especially to compensate for such large wind or solar farms. So, and this is this modern technique for energy development. It's not actually very modern. It has been around from the 1980s. So how it works, I'm going to explain briefly how it works. So we have two reservoirs. We have the lower reservoir and the upper reservoir, and this basically works on change from gravitational energy to a kinetic energy. So let's say we're in day and we have excess solar energy generation. What we do is that electricity is used to power a pump. This pump is alternately going to be to transfer this water. We have two lakes, one at lower altitude and one at a high altitude. So this electricity will power the pump, and the pump will elevate the water from low to high, and thus gaining gravitational energy for this water. And then when we're at night, for example, and we need this energy, okay, the gate is opened and the water is allowed to go from upper reservoir to lower reservoir, and this gravitational energy is therefore transformed into kinetic energy that will turn the turbine and produce electricity. This is the large means of storage. It's using terrain geography, but this also makes it kind of not very usable on a large scale, because not all countries have such terrains. But work is being on progress with that, and as I said, it's been around since the 1980s, and it currently stores almost 168 gigawatts globally. So yeah, I talked about all these. Another similar method is compressed air. So instead of using the excess electricity to pump water upwards, we're pumping air into tanks, and this air will be very highly compressed. And when we want the energy, the tank is depressurized, and the air is outletted at very high velocity, which turns the turbine and produces electricity. However, this is very kind of unsafe right now with the current technology, because the main problem is with tanks that can capacitate such high pressure. So the current preference is salt caverns, because salt withstands very high pressure. Ultracapacitors, they are another sort of capacity innovation. Energy is put in electric field. It's not like a battery. It can endure in excess of 1 million charge and release cycles. It has been growing quickly lately, but it is very promising. But currently, it's still in R&D phase in terms of using it for a very large scale. Net meter. Now we've ended the energy storage methods, the main ones that can be used on a large scale. Now let's talk about net metering. Net metering is used in terms of first of all, defining net metering. It's a billing mechanism in which the consumer becomes a provider at certain times. So if you're producing electricity that you don't need, you can actually distribute it across the grid. You can send it to the grid, and the grid distributes it to the users, and it's shared and allocated as deemed necessary. It's currently an average of 20 to 40% of produced electricity goes into the grid, and it allows a shared electric network. Everyone is a stakeholder. Not excess electricity is going to waste. It's going to the grid, and you're actually somehow getting paid for it. So, so this is very useful in terms of making everyone supplying this grid. As for fossil fuels, so as we know, we're still at a stage where we need fossil fuels and to suffice or to handle the rest of the power requirement or the energy demand from consumers. But if we want to make renewable energy on a large scale, we can use natural gas as transitionary gas because it's much cleaner than coal or crude oil. For example, for each gigajoules of electricity of power generated from natural gas, we have carbon content of 15.3 kilograms. In coal, it's 26 kilograms of carbon, and in crude oil, it's 20 kilograms of carbon. So there's a huge difference, and this transition is very helpful. And natural gas has a very huge potential for improving the energy mix as we transition from fossil fuels towards renewable energy. So, of course, as we said, natural gas is expected to become 22% of all fossil fuels used and the total primary energy demand. However, all fossil fuels will decrease to 57% by 2035. However, on the other hand, electricity demand is expected to increase, growing population, and so on. So we're also going to need more gas or renewable energy. So with more renewable energy needs, we're going to have more gas needs. So and in stats and the numbers, the demand in coal is continuously decreasing as it's being replaced by renewable energy and natural gas. And by 2040, it's expected for natural gas to be the second largest contributor by developed countries. As for another method, as we said, we don't just need to make proper use of the demand of supplying the electricity. We also need on the demand side from the consumer behavior. So therefore, we need low consumption appliances and technologies. So, for example, just like Samsung and LG are pioneers in this field. So I'm going to give an example of a smart fridge. It's developed by Samsung, so by LG, sorry. So the fridge does its cooling cycles when we're having excess electricity. So for example, if we're having peak time electricity and peak generation, and we don't know what to do with that power, like for example, the fridge is using it in order to do the cooling cycles, and which will remain until the power cuts off, so that it can handle that. So the cooling cycles are really timed. Also, for the same thing for washing machines that use electricity on times of when electricity is readily available and cheap. So also this is very, like, for example, if there's a football match, for this example is always used. If there's a football match, there's a very high demand on electricity. So in that time, for example, we don't use the fridge. The cooling cycles are turned off, or we don't use the washing machine. So it's all integrated and connected. Another type of energy that is more expected than solar and wind is hydropower. But hydropower can be like harnessed in three ways, mainly. Dams use the steady flow of rivers. Rivers are always there, like mainly main rivers like Litani or Asya, for example, here in Lebanon, not the springs. So we can build dams upon that. However, it's very publicly opposed, as it has many disadvantages: environment, community displacement. Also, it can be very destructive to the biodiversity of the area and local communities. And it has very high construction costs, and this is very opposable. So that's why it's always controversial. We also have waves. Wave power may be harnessed, but it's not a constant renewable energy source. It's according to weather conditions. However, very modern and promising energy in terms of hydropower is tides. tide power is always there. We always have tides in the ocean. It's mainly in the oceans, not the seas. Uh, so it's like offshore dams, not on land, but offshore. But so they are kind of same as controversial for the biodiversity offshore. But however, there can be more simpler and smaller ways to harness this power without actually having such a high footprint. For example, we can put a pump on the seabed, and this is usually used now. Or we can, instead of having a horizontal dam offshore, we can have a vertical dam in order to harness the tidal energy in a vertical manner, the vertical extent of tidal energy. Another kind of overlooked energies are geothermal and biomass energy. So geothermal is kind of not used now because it's not economical with the current energy prices. It might be more economical if electricity prices are up or we have more demand. However, it's also used for providing heat rather than electricity nowadays, because geothermal energy is just heat coming out of the ground, so it's just readily available heat. Also for biogas and biomass actually, they are mainly local because they are used for short-term heat generation, for example, incinerators. But they can also be used for pyrolysis, for gasification, in order to have more energy means or fuels. And they also double as a useful way to get rid of waste. So this is actually more environmentally friendly as well. Another way of harnessing energy in a way that's sustainable is cross-border grids. So for example, I'm going to give the example of the US. In the US, some states are windy, some states have rivers, some states have deserts, for example, like Texas. So we can connect an entire grid that's one state helping the other in terms of one state is missing some kind of element. So this uses the extent of geography, of terrain, natural elements, and weathers of different states. So we have solar power in Texas, we have wind power in Illinois, have hydropower in Chicago, different states with different powers that can supply each other when in needs over one grid. This is a project in the US. This is being worked on. But however, in Europe, actually, there are 3 cross-border grids from France, Germany, Spain, and 21 other countries. It's the biggest one, 345 kilometers square. It's the continental synchronous grid. There's the Nordic grid and the Baltic grid. However, there are more theories or more projects being studied in order to connect, for example, Europe and North Africa in the near future. So in conclusion, in the near future, fossil fuels will remain essential, but we can gradually abandon that to use more renewable energy. But for that, we need advancements, we need technology, we need to see how things are changing over human history in order to learn. And as we see, the energy sector has actually matured, but it still has a lot of things to go on. And as the world turns into more sustainable agendas, I can't hear correctly. Yeah, as the world turns into more renewable energy, we need more sustainable agendas in decision making, and this will help these endeavors. So the solutions can be concluded as follows: changing our energy demand profiles, improving the efficiency of current electric appliances, incentivizing small-scale appliances of renewable energy and all households while applying proper net metering policies, while optimizing and innovating better energy storage systems. So there's no single solution. Thank you.
Okay,
Any questions?
Mahdi, thank you.
Thank you.
Mahdi, first, if you want to suggest one of the renewable energy techniques for Lebanon, what you suggest to use?
For Lebanon, okay, there are a lot of elements in Lebanon. For example, we can't use dams because there have been failures in Lebanon. We don't have the proper geography or terrain. We can't use waves. We don't have that much sea exposure, nor tides. We can really use low consumption appliances because there's a lot of energy leakage in Lebanon. That's the main problem. Natural gas can be actually very promising, since we are on the verge of discovering natural gas, but maybe not now, maybe in 10 years. But for now, there are a lot of plans in the 2060 agenda of Lebanon, 2026, sorry, agenda of Lebanon, of becoming more reliable on natural gas. That's very good. Net metering is actually currently in use in Lebanon. The EDL is actually accepting applications for net metering in Lebanon, and it's not actually very powerful policy in Lebanon because they don't pay you actually. It's rollover. We can't actually use compressed air because the hazards, and Lebanon doesn't have that much of capacity or underground storage. Pumped hydro can be very useful because of the terrain in Lebanon, and that's the main thing. In Lebanon, we have the terrain, and it's our advantage, and we can use pumped hydro. Just like Iceland, by the way, pumped hydro is very used in Iceland because they have terrain that's between coastal and mountain terrain.
And wind energy also, I think, can be convenient in Lebanon.
Yes, but أنا كان بحكي إنه in terms of the solutions for intermittency. Yeah, for example, هلا بعكار in Akkar there's now a project to harness wind energy. So yeah, we are our environment or our weather allows us to do that. But then we have to think about its intermittency, and that's my point. You know, the intermittency of renewable energy in Lebanon can be overcome by pumped hydro, but to harness the existing potential.
Don't you think that it can be also overcome by wind energy?
No, but I mean انه wind energy لما ما نستعملها شو بدنا انه بدها تصير بدنا fossil fuels. So حسب overcome what. So اذا نحن بس ما نتكل على wind energy ما فينا بس نتكل بدنا pumped hydro. بس اذا نحن fossil fuels, yes exactly. مثلا نحن في عنا we have wind day and night. بس
so if you want before getting to the stage of 100% using renewable energy, we can use hybrid systems as a solution.
Exactly. Yes, exactly. So hydro system between wind energy. بس كمان نحن بلبنان إنه في عنا شتوية وصيفية إنه بيفرقوا كمان. So we have to take that into consideration.
Okay. And between the systems you suggested, which one was shown to be more efficient or most commonly used in general?
Most commonly used currently هلا من ناحية الستورج حاليا بعدنا على electrochemical batteries لأنه it's small scale. أكترية الستورجز عم يستعملوا electrochemical batteries لأنه مثل ما قلنا إنه بعدنا we're at early stages of deploying a 100% renewable energy plan. So still enough. لهلا electrochemical batteries are still enough. But the second most used يمكن pumped hydro. But for now these are enough, and work is mainly being done, and the research and development is being worked mainly on these electrochemical batteries. Alkaline and lithium, and making them more acceptable in terms of shelf life, cycle life, price, and so on.
Okay, thank you, Mahdi.
Thank you. How was it?
It was fine.
Okay. صراحة أنا كنت عم بفكر أعوض بالبرزنتيشن لأنه بالبيبر شوي خبصت شوي بالبيبر, so I was